Alright guys, today we're going to take a look at the double replacement lab. So if you look at your lab paper, the first example we're going to do is the class example actually, which is the lead 2 nitrate plus sodium iodide. So I'm going to mix those two together, just a couple drops of each. We're going to record our observations, and then we're going to see which ones form a reaction, or where a reaction takes place. We might create a precipitate for some of these or a gas for some of these, and there will be some that are also a no reaction. So let's take a look at those one by one, and then we'll take it to the next step after that. So we'll start out with lead 2 nitrate and sodium iodide and see what we end up for this one. Alright, so here's the lead 2 nitrate. Here's this sodium iodide. Alright, and we can clearly see that we have a yellow precipitate being formed for that. Alright, so you can take a second and write down your observations, and then we'll go on to number 2. Or actually it'll be the first real one that we're going to do that is not the class example. So official reaction number 1 is copper 2 sulfate, which is right here. And we're going to combine that with barium chloride, which is here. Okay, so if you take a look at that, you can see that we have like a milky white precipitate that's being formed. So the copper 2 sulfate is this blue color here, and the barium chloride is just a clear solution. All right. Okay, moving on to the next one. So it's actually number 2 on your lab paper. That is going to be potassium chromate, which is here. We're going to combine that with silver nitrate. So silver nitrate we used in a couple labs so far this year. Alright, so you can see what happened there. Alright, dark, deep red precipitate being created. Okay, moving on to the next one, we have silver nitrate, so we'll use that again. Here's that one. And we're going to combine that with barium chloride. So we've used the barium chloride already. Let's get that back out and use that. Okay, and if you take a look at what's going on there, you can see that there's it might be hard to see with the white paper as a background. It's a milky white precipitate again. Okay, let's move on to the next one, number 4. Potassium chromate, which we've used already. And we're going to take a look at sodium hydroxide. So strong base actually. Here's sodium hydroxide. Okay. Ignore that little pink that's occurring there. We're going to talk about that later. That is contamination left from a different lab on acids and bases, and that's actually a phenolphthalein indicator reacting with the NaOH to give you that pink color. So let's ignore that. And it looks like nothing much really occurred there. So we had the potassium chromate, which was like a clearish yellow liquid, and the sodium hydroxide, which was a clearish, like just completely clear liquid, and we didn't have much of a precipitate or anything occur other than that contamination from a different lab a year ago. Okay, moving on to number 5. We have copper 2 sulfate. And we're going to combine that with lead 2 nitrate. Alright, so you can see what happened there. We have a precipitate again for that one. Okay, next one, sodium carbonate, which I have right here. And we're going to combine that with hydrochloric acid. So here's our hydrochloric acid when we combine that. Okay, I definitely saw some bubbling occurring. A little bit more, just for the heck of it. Alright, you still see some bubbles in there, in that well tray. And let's go on to the last one, which is potassium chromate. And barium chloride. Okay, so it looks like we have another milky white precipitate there. Some of the yellow you see is just some extra potassium chromate left. If I add more of the barium chloride, and make a little bit more of that precipitate. And that's what we end up with for that one. So it looks like we had one of them that was a no reaction, which was up here, right? And it looks like we had one that had bubbling. All the rest had a really neat color change and a precipitate occur. Okay, that should take care of the double replacement observations. We're going to take a look next at what we do with these and how we continue on with them. All right, guys, thanks.